Okay, so in this video we're going to talk about revenue and cost functions. So we'll use some basic principles from economics to start out. So the law of demand says that if the price goes up, the demand goes down. So the simplest models for price versus quantity, demand curve, price versus quantity, are lines. And then after that, quadratics. So let me show you what I mean here. So if this is X, this is quantity, and this is P, or price, the simplest model will be just a line. Or if you wanted a little bit of curve, you could use a quadratic here. Okay, so that's the law of demand. Now, in a competitive market, revenue is price times quantity. So if we write this out, R is going to be P, price, times X, quantity. So if P is a line, then R is going to be a quadratic. If P is a line, then R will be a quadratic, because it's going to be X times that line. So there's the R corresponding to that P. And if P is a quadratic, then R is going to be a cubic. Okay, so you can see how we get polynomials from the law of demand and revenue as price times quantity. Okay, so let's do an example. So if the price of some item is $100, no units will be sold. However, if we lower the price to $50, then 1,000 units will be sold. Assuming the demand curve is linear, find the revenue curve and sketch its graph and maximize. Okay, so let's start by drawing the price curve. So when the price is $100, then no units will be sold. When the price is $50, then we can sell 1,000 units. And if we draw a line through those 2 points, we'll get that line crossing the x-axis at 2,000. Okay, so the equation of this price curve. So let's use the point slope form of the line. And we'll use P instead of Y. And then the slope, well, the slope is rise over run. The rise is negative 100, and the run is 2,000. If we look at these 2 points right here on the x-axis and y-axis, so negative 100 over 2,000 is negative 1 over 20. And then a point on this line, we can use either the 2,000 comma 0 or the 0 comma 100. That's going to be our point. And then we can combine those, we'll get p minus 100 equals negative 1 over 20 x minus 0. So p equals negative 1 over 20 x plus 100. That's our price curve. And you can check that this works. When you put 0 in, you get 100. That's the price when no units are sold. And when you put 1,000 in, you get 50. Negative 50 plus 100, which is 50. Okay, so now we can do our revenue. Our revenue is going to be price times quantity, or negative 1 over 20x plus 100 times x, which is negative 1 over 20x squared plus 100x. Let's graph this revenue. So it has a 0 at 2,000. And it has a 0 at 0, like so. And 1,000 is going to be, by symmetry, is going to be our max. Let's compute the revenue at 1,000. So we'll get negative 50,000, 50K, plus 100,000, which is 50K, 50,000. And I told you the zeros are 0 and 2,000. Let's just check that. So if we put 2,000 into this formula, can check that this is indeed going to be negative 200,000 plus 200,000, which is 0. And so R of x has a max at 1,000 comma 50,000. You could identify this max with the derivative. So if you look at the derivative there, the derivative of the revenue function is 0 at the max. So one way of finding this max algebraically without graphing it is to take the derivative of this revenue function. We'll get negative 1 over 20 times 2x plus 100, which is negative 1/10 x plus 100. And we set this equal to 0. And we'll get x equals 100 times 10, which is 1,000. So where the derivative is 0, this corresponds to a max of the revenue function. And we'll use that fact more in the future. Okay, so now let's talk about constructing a cost function. So cost is the sum of fixed costs and variable costs. Let's consider an example. So suppose it costs $5 to produce each item and $10,000 to set up production. We want to find the cost as a function of X items produced. So the cost is the fixed costs plus the variable costs. The fixed costs are $10,000, and the variable costs are 5 per item, or 5 times x, where x is the number of items. So there's our cost function. Our cost function is 10,000 plus 5x. All right, I hope you found this video on the cost and revenue functions useful.